Hi, today's topic, electron affinity. It's one of the trends that we're supposed to discuss during AP Chem. And I guess maybe the first thing we should think about is what is affinity? So affinity is if you like something. Um, so to use it in a sentence, you could say, I have an affinity for the music of Ronnie James Dio. Okay? So it's something that you like. So what kind of elements like to get an electron? Okay, so essentially we've got two groups of elements. So we've got metals and nonmetals. There's also metalloids, but we're not going to really talk about them because just like you would think, if you've got metals doing one thing and nonmetals doing the other thing, then the metalloids are just sort of right down the middle. But when we think about it, an electron affinity is defined as the amount of energy lost when an electron is attracted in. So essentially, when you lose energy, you become more stable. So we are looking for elements that actually want an electron. They have an affinity for an electron because when they attract that electron, they become more stable. Now, let's look at our two groups of elements. Okay, metals. Do metals want to attract electrons? Do they become more stable when they draw an electron to it? No, of course not. Metals only have, that was my headphones, don't worry. Metals only have 1, 2, or 3 valence electrons, so metals, they want to lose electrons. Okay, and so they have low electron affinity. They don't like electrons. They don't want to get electrons near themselves. So metals, their behavior when forming ions is to lose electrons, and they have low electron affinity. Now nonmetals. So when you look at, let's say fluorine, he's simple. 1s2, 2s2, 2p5. Okay? So up, down, 1s2, 2s2. And then you put in that 2p5, up, down, fill it in correctly. Look there. The only thing that is keeping fluorine from having a noble gas configuration, which makes the element very stable, is one electron. So do you think fluorine's going to attract an electron to itself? You're darn right it will. Okay? So that guy has a high electron. He has a high electron affinity. He wants to attract the electron to itself. And so, boom. When fluorine attracts that electron, it has a complete valence shell. It's very stable. And so it releases energy and, it's able to then react as a -1 ion, which we will see when we work on ionic compounds. But electron affinity is just how much you want an electron. Here's the rule. Nonmetals have higher electron affinities than metals, which have low electron affinities. The closer you are to fluorine, because fluorine is relatively small and has this almost finished, it only needs one, because it's almost finished, it has the highest electron affinity. So fluorine, highest electron affinity, the closer you are to fluorine, the more your electron affinity.